was invited as part of the industry seminar part of this. So, although we do a lot of research with universities, we also tend to do a lot of research ourselves. But we're not going to present one project because, again, I'm from the industry part and not from the academic part itself. Just to give you an idea of what we do, if it's going to work. So this is the factory we have in Eindhoven. This is where we produce our products. What we mainly do as a company is sell 3D concrete printing equipment. So we are machine sales for 80% of what we do. We produce here with one machine. This is also where we do our R&D. And you can see the setup is on an ABB robot on track. We print in factory only. So within the concrete printing industry, we are one of the parties that basically you can split concrete printing into printing houses and not printing houses. And we are one of the companies that is very good at not printing houses. So anything that is not a house, we are very happy to do for you. There are several machines of ours that are being used worldwide by our clients to print houses, even on site, so it is possible. But when we print in factory under controlled settings. So in the concrete printing industry, you have this divide between one component and two components. For those of you who are not aware, one component is the idea of having a base mortar mix with some type of accelerants or rheological properties that when you mix it with water, you send it to the print head, which is a steel pipe. You can print your object. It takes about 9 to 30 minutes to harden. And this is useful for housing printing because you have a very long stretch. What we do is something different. We have a two-component system, and that means that we add no accelerant in the mortar. So our mortar is a base mix with no accelerant, no powder. We only add a liquid accelerant in the print head. And so this inside concrete printing is a bit of a niche. And there's not a lot of companies that sell this particular technology because most of the companies are busy in the construction industry. We heard this morning from Professor Dillenberger as well about the added value in construction, and I have the same point to make as well. This is one of the reasons why I think it's important to automate. But again, most of the concrete printing is in construction for this reason. And as a company, we enjoy doing the more high design type stuff, more architectural details, facade elements, columns, etc. And so even though that's still construction, it's also the architecture side. We've sold machines worldwide. I think we're now up to 53 in 24 different countries, 6 continents. And we do a lot on research side, so about half the machines we sell for the research side. And then you get a split between startup companies and construction companies that already have some affiliation to the concrete or asphalt market, right, a construction market. But also a lot of startups, so a lot of young people that are buying the machine and starting a company. So what we do is we sell hardware, we do printing as a service, we do software, and we do consultancy, because a lot of people still don't really know what's possible. From the technology side, I explained just now the difference between this 1K and 2K. So we sell both because the basis of the technology is the same. So the basis is a concrete or mortar pump in our case. And if you have a simple mix, you just have a steel pipe. But for us, we have the more advanced with 2 components, and then we mix the second component in this print head. Now, one of the nice features of our print head as well is that once we finish printing, we can clean our system, and it is a self-cleaning print head. It's about 99.5% self-cleaning because we flush the system from our pump, and we have a patented lining inside that allows for the self-cleaning aspect, which saves some time and hardship for the users. A system like ours looks like this. So you have your robot on track, print head. For those of you this morning who were at Professor Dillenberger's presentation as well, that's a similar system, right? We have a more, I think, industrially ready version, an off-the-shelf version that we sell in its completeness, including training, installation, software, slicing software. For those of you who know, and everybody in this room probably is aware of Rhino Grasshopper and how it's used a lot in 3D printing. And we built our slicer in Rhino Grasshopper as well, like most people do. But we've kept ours in Rhino Grasshopper, have no skin on the software, so that, because I think we're still quite early in the innovation, And I think that you need to be able to control all the parameters. So we teach our clients how to use Rhino and Grasshopper instead of having a skin on the software, because I think you need to want to be able to iterate and mess around in the software. It's very important to have that control. But that's the basis of the technology. We're down at the BAM stand as well. If you want to talk more on tech, I'm more than happy to talk to you about it. I think it's a little bit more inspiring to talk about some projects. The very first project I ever did was a 3D printed concrete canoe for the yearly concrete canoe race. This is the 4th iteration we've had, and we do it every year. What we focus on as a company is we see a lot of potential in facade elements for us, in columns, in planters, interior design, and in public spaces. So we do projects like park benches, playgrounds, we do facades, we do parts of facades, and we're finally seeing that architects are finding us. So a lot of people that have joined us in our journey over the past 8 years have come to us and say, oh, you must be so popular with architects. I think I can count on 2 hands how many architects have visited our facility. So, and I've asked architects afterwards, why is this the case? And a lot of them have said to me, because they're now, I'm in the industry, that they struggle a lot with the fact that they are taught and they have a business to generate value within a certain set of parameters. So architects are very good, of course, at creating unique things, but also have a business responsibility within a certain set of parameters. And so jumping to 3D printing of concrete, which is a risk, is not something that many architects are willing to take, which I fully understand. Nevertheless, I think an architect would understand what the potential is here. And these columns, for example, we fill these with rebar, and then we fill them with concrete to avoid all types of standards and the lost formwork strategy. So even for an architect, this is the kind of thing we want to see. And now finally we see the architects. We worked with Zaha Hadid recently, and we're working with some other large, famous NDA'd architecture firms. We're finally seeing that they're understanding the potential, right? And they do want to be in the forefront, especially when they're printing the larger projects. So they are coming. But in the meantime, we had to figure it out ourselves. So one of the first projects we did as well was a compression-only structure. We got a small subsidy to do a tiny house. This is what came out when I tried to make a tiny house. That's why we don't do houses. It also took us 4 years to figure out how to do this. So really from zero technology knowledge to printing this took us 4 years to develop the 2-component technology. The nice thing about it is the lack of formwork. And it is one thing that's not spoken about enough. We used no permanent formwork in this project. This is all temporary formwork, and that's fun. That was just a nice way to show that. We have a nice project with other people here, with Lübeck. TU Lübeck, we had a beautiful project for them where we printed 208 objects in 2 days. Luckily, it was their problem to assemble it, so for us it was a nice project. Then this is the Zaha Hadid project I talked about real quick, and this was a whole nother challenge. This was for the Milan Design Week, and of course we were honored to be asked even to do it. We got a total of 3 weeks notice because the party that would have printed it in marble powder couldn't print in this size. So we got 3 weeks notice to print and slice this. And for those of you who know slicing, this is an amazing job. And what we actually had here was 3 arches, one 4.5 meters high, one 8.5 meters high, and then this marble arch. So the marble arch is milled. And then we printed a 4.5 meter high pavilion, and we printed an 8.5 meter high pavilion in 3 weeks, including all slicing, which is insanity. And I don't think many companies, especially in concrete printing in the world, could have done it. And then they only gave us 5 days to install it, which we were not responsible for, and there just wasn't enough time. So somewhere in the world is another 8-meter pavilion that's supposed to go on top of these two, printed in 3 weeks. Just to give you an idea of the prototype potential with this technology, and the slicing that can be done if need be in that time. This is another early example of what we did with topology optimization, one of my favorite subjects as well, where we took, you guys are all very much aware of topology optimization, what's possible, but for many people that don't know, this image speaks to them of understanding what the reality of topology optimization can be. In research side, we've also done weird things like adding a wooden panel, wooden piece of wood to the end of the robot with the TU Eindhoven and shaping sand into double curved molds and then printing over the top of them to make these facade type elements. This is the only render you'll see in our presentation. Be aware this is a render. The other stuff is not. For ourselves, and I gotta keep time in mind, but I have a minute, so I'll explain the longer version of the story. I got into 3D concrete printing because I really like 3D printing, but I also like architecture. And what inspires me in architecture is I was always inspired by old churches. Went from youth seeing design and you think, what does this have to do with an old church? In the Netherlands, where I come from, in Utrecht, there's a famous tower called the Dom Tower, which is the largest church tower in that city. It was renovated in 2025, and the old elements were sold off. So instead of destroying them, they were sold off. And I immediately went and bought 10 pieces of the old church. And what we did was we scanned them, and we then, what we are doing now is scanning these different elements, reprinting them and milling them. To make them look like the originals, to kind of have that conversation about restoration, which is a cool but obvious idea to do, right? It's something very simple. But we want to take it one step further. We want to also show that you can reintegrate these old elements from these churches with modern technology. So we're now combining these columns of digitally manufactured forms with the old church elements and making a new whatever it's going to be. And to do that, we mill. And the milling experiments have also shown other patterns that we can create. And what's really nice about 3D concrete printing with two components, which is the technology I explained is our niche, is that once you print it, it's set in 30 seconds, but it's still in a leather state, as has been explained to me. So you get about 3 to 4 hours to still manipulate it a little bit with a sponge or with whatever you like. But we use a wood mill. So it's not even a concrete mill, it's a wood mill. So it's an extremely low energy interaction where we can just mill that because it's still semi-soft. And the PhD that's doing this for us, we sponsor a PhD with the European Space Agency, and this is for buildings on Mars. Because the other idea, which is interesting here, is that we can create architectural connections that are flat, which is obviously a problem in 3D printing because you have the curved structure of all the layers. So if we can mill those, we can get a much tighter connection between the 3D printed objects. So those things combined, even though there's no commercial applications for us for this right now, make it an interesting area of research. What I also love is columns and the potential, and then what we are very strong at this moment is the potential of color, which is very easy to add. We recently went a little viral with this video, that's why I wanted to show you as well, of when we started, which is back 2018, and how it's going so far. And this is 2000, a little bit earlier, even 17, of your basic beginnings of things collapsing. And then now us doing the non-planar activities, the milling activities, and this insane slicing. One first time right. Every single object produced first time right in 3 weeks for the Zaha project is in there as well. With the little pièce de résistance of a little fun we had on a Friday, seeing if we could do 90 degrees. And then the engineers taking it to the next step to see if we also go back 90 degrees. And we like to test things to failures just because, why not? Because we're going back up. And at some point, something's got to give, and you're going to see, hopefully, the layer delineation and collapse. You won't see that on Instagram, but that is also the fun part. But I mean, that's just awesome. It's just fun. But it's, yeah, I'm 30 seconds less, so that's good. And this one you'll see downstairs. You're going to see it upside down for safety reasons, because it's a little bit more stable. But this is what we love. The color, the precision, the manufacturing capability, and I think there's a market out there for these type of items. Any questions?
So,
I hope no one fell asleep with the coffee break.
Thank you for the presentation.
Yeah, you're
Very
welcome.
interesting stuff.
So much more.
For sure. So I've been wondering about the Saadit collaboration.
Yeah.
Because you said you had to slice it yourselves.
Yeah.
I mean, obviously this project didn't go as they intended, but
Yes.
would you say if we as architects provide already the print path, is that
No.
something you would prefer, or do you really want to take control?
Zaha has Zaha Code, which is obviously an excellent group of guys that can do this too. But what we noticed is that our guys were easily as capable in Grasshopper as they were. And of course, it's our machine. So because they gave us literally 3 weeks to finish this project, which is patently insane, the longest thing and the most, the bottleneck was the slicing, because it was that complex. So we would literally finish a slice an hour before we started printing it. That's how hard we were working on these slices. So yes, they could have done it if they would have given us some type of normal timeline. But in our case, because we know our machine so well, it makes sense for us to do the path. And I wonder if architects should really have coding departments when you have so many different types of slicing.
Well, maybe bottom line is, for if we just want the shape, it's probably best you do it, and if we want to design with the layer parts.
Yeah, and there was, we had 3 weeks of print. We had about 2 weeks of conversations about the design itself. But that was mostly with how large will the inserts be for the steel cables, for the compression, what thickness, and a lot of things went wrong because 2 weeks isn't enough. You know, what is your intersection, the neoprene? So these conversations were had, and some angles could not be printed, so we would change them a little bit. So yeah, there's a conversation there. But I feel right now that we know our machine so well, that we know the limitations.
Yep, thank you.
You're welcome.
No more hands? Seems so. Oh.
A pity question.
You talked about the low number of architects that came to your studio, and I mean, your business, if I understood correctly, is selling the machine and the software and consultancy. However, at the end of the day, somebody needs to design those things which are worth printing.
Yeah.
So we are back to the architects.
Yeah.
How can we change that? What is the potential, or what kind of experience did you make to increase the number of architects who have an interest in your
That's
work?
interesting. So I will take that question as what is my responsibility in that, not as what is the responsibility of the architects. Because what I've seen is that when I started the company, we had zero funding, financing. We started to sell machines because that's what made money. If we could sell, if this was where the money was, that's all we would do is print beautiful stuff. That's our thing. But we sell machines, and we got good at it because that's where the money is, and that's fine. And we were happy to do it because the machine didn't exist; it had to be made. But now we're at the point where, as a company, we have a machine that's off the shelf that can be installed, but we also see that we're at the forefront of what is possible, so we want to expand into a production facility as well. But when we do that, the difficulty is that that's a completely different style of sales. So we need to split our sales team and our production capacity into a completely different business strategy model. And when we do that, we have to look, okay, how are we going to change our sales strategy into one that incorporates generating ideas from the market, and then it's up to us to reach out to these architects and explain to them what the possibilities are, which we haven't done in the past because we didn't have time, money, or resources, right? So we have to do a lot of the outreach as well, because I think that when you see this presentation, and there's many architects here, I would imagine, that you understand, hey, there's a thing possible, but we have to plant that seed. So it's up to us as well to go and outreach a lot. But it costs time and money. But it's going to start slowly from now, in my opinion. Or if anybody has an idea, contact us and we can make it.
Do we have more questions?
Maybe comment on the discussion.
Yeah, you can just come to the booth after. We have lots to talk about, apparently.
So you mentioned you're selling the machines, but you also want to get into manufacturing.
Yep.
I think that's might be a good combination actually, because like if we do public buildings for the tender, there need to be 3 companies that can do it. So
Yep.
you're already creating that yourself.
In the beginning, when I had to strategize a lot about what the company was. There was always a conversation between, are we a printing company or are we a technology company? And it cost me a lot of mental energy. And at some point I decided, especially early on in innovation, which we're still at, that it's impossible to be one or the other. At our innovation, we had to be both, because we had to test what was possible in order to know how to better the machine. So we have been both and have stayed both. And the milling is an example of that, right? We're trying to create the new opportunity within concrete 2K printing. We have to be both. And it's a weird morph, but we have to be both.
Yeah, looking forward to it becoming established.
Yeah, me too.